Welcome to Space Channel. At here we have all about space and galaxy. Thank for your heading. Now we'll find about our solar system. A solar system is a star and all of the objects that travel around it, planets, moons, asteroids, comets, and meteoroids. Most stars host their own planets, so there are likely tens of billions of other solar systems in the Milky Way galaxy alone. Solar systems can also have more than one star. These are called binary star systems if there are two stars, or multi-star systems if there are three or more stars. The solar system we call home is located in an outer spiral arm of the vast Milky Way galaxy. It consists of the Sun, our star, and everything that orbits around it. This includes the 8 planets and their natural satellites, such as our Moon, dwarf planets and their satellites, as well as asteroids, comets and countless particles of smaller debris. Our solar system extends much farther than the 8 planets that orbit the Sun. The solar system also includes the Kuiper Belt that lies past Neptune's orbit. This is a sparsely occupied ring of icy bodies, almost all smaller than the most popular Kuiper Belt object, dwarf planet Pluto. And beyond the fringes of the Kuiper Belt is the Oort Cloud. This giant spherical shell surrounds our solar system. It has never been directly observed, but its existence is predicted based on mathematical models and observations of comets that likely originate there. The Oort Cloud is made of icy pieces of space debris the sizes of mountains and sometimes larger, orbiting our Sun as far as 1. Six light-years away. This shell of material is thick, extending from 5,000 astronomical units to 100,000 astronomical units. One astronomical unit, or AU, is the distance from the Sun to Earth, or about 93 million miles, 150 million kilometers. The Oort Cloud is the boundary of the Sun's gravitational influence, where orbiting objects can turn around and return closer to our Sun. The Sun's heliosphere doesn't extend quite as far. The heliosphere is the bubble created by the solar wind, a stream of electrically charged gas blowing outward from the Sun in all directions. The boundary where the solar wind is abruptly slowed by pressure from interstellar gases is called the termination shock. This edge occurs between 8,100 astronomical units. 2 NASA spacecraft, launched in 1977, have crossed the termination shock, Voyager 1 in 2004 and Voyager 2 in 2007. But it will be many thousands of years before the 2 Voyagers exit the Oort Cloud. Our solar system formed about 4.5 billion years ago from a dense cloud of interstellar gas and dust. The cloud collapsed, possibly due to the shockwave of a nearby exploding star, called a supernova. When this dust cloud collapsed, it formed a solar nebula, a spinning, swirling disk of material. At the center, gravity pulled more and more material in. Eventually the pressure in the core was so great that hydrogen atoms began to combine and form helium, releasing a tremendous amount of energy. With that, our sun was born, and it eventually amassed more than 99% of the available matter. Matter farther out in the disk was also clumping together. These clumps smashed into one another, forming larger and larger objects. Some of them grew big enough for their gravity to shape them into spheres, becoming planets, dwarf planets and large moons. In other cases, planets did not form. The asteroid belt is made of bits and pieces of the early solar system that could never quite come together into a planet. Other smaller leftover pieces became asteroids, comets, meteoroids, and small irregular moons. The order and arrangement of the planets and other bodies in our solar system is due to the way the solar system formed. Nearest the Sun, only rocky material could withstand the heat when the solar system was young. For this reason, the first 4 planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. They're small with solid, rocky surfaces. Meanwhile, materials we are used to seeing as ice, liquid or gas settled in the outer regions of the young solar system. Gravity pulled these materials together, and that is where we find gas giants Jupiter and Saturn and ice giants Uranus and Neptune. Our solar system is the only place we know of that harbors life, but the farther we explore, the more we find potential for life in other places. Both Jupiter's moon Europa and Saturn's moon Enceladus have global saltwater oceans under thick, icy shells. There are more than 150 known moons in our solar system, and several more awaiting confirmation of discovery. Of the 8 planets, Mercury and Venus are the only ones with no moons. The giant planets grab the most moons. Jupiter and Saturn have long led our solar system's moon counts. In some ways, the swarms of moons around these worlds resemble mini versions of our solar system. Pluto, smaller than our own moon, has 5 moons in its orbit, including the Charon, a moon so large it makes Pluto wobble. Even tiny asteroids can have moons. In 2017, scientists found asteroid 3122 Florence had 2 tiny moons. Human beings have studied our solar system for thousands of years, but it was only in the last few centuries that scientists started to really figure out how things work. The era of robotic exploration, sending uncrewed spacecraft beyond Earth as our eyes and ears, is only a little more than 55 years old. A fleet of space robots is out there right now exploring destinations from the Sun to distant planets orbiting faraway stars. Thanks for your watching again. Please like, subscribe to watch more videos, and let your feedback at comment below. Thanks.